Okay, we're in section 87 now. And again, the contents, examples, exercises, it's pretty routine. What are we doing over here? This is Ron Bannon's draft version or an adaptation of Webster Wells's Advanced Course in Algebra dating back to 1904. The PDF document is being made available to the Prison Mathematics project, and we're going to just move forward in it. I do want to point out, moving forward, if you do have questions or concerns, you can reach out to me by email. My email address is Bannon, that's B as in boy, ANNON.US. All right? So what I want to do is just scroll through the document. And this is a document about partial fractions. Yes, you're expected to read that. No, you're not reading as I'm scrolling through it, but you're expected to read that. But I'm sure you're rightly confused by what's going on there. So I'm going to talk about, the way I approach problems might be different than the way Webster Wells approaches problems, but I'll go through it. And what I'm going to do is over here is, certainly this is a partial fraction problem, and it seems reasonable. Let me get my eraser. Let's get some problem here that maybe I didn't erase the document completely. There's stuff over here. I want to get rid of that. Let me go back to my pen. And I can say, there's a good chance this thing's going to divide nicely into two fractions where the denominators would be 3x minus 1, and the other denominator would be 5x plus 2. That seems reasonable. You'd get a fraction like that where the denominators are product of those two. My issue is I don't know what the top is. So I'm going to say A and B. This is typical. What I'm going to recommend you do, though, is multiply both sides by the LCD. Let me write the LCD down for you. The LCD is 3x minus 1, 5x plus 2. Well, what I'm going to do is multiply both sides by the LCD, and you're going to get 19x plus 1. You can get A times 5x plus 2, and you're going to get a B, 3x minus 1. Now, what most people do at this point is they expand it. This can be very difficult, by the way, but expanding is not a bad idea. So we're going to get 19x plus 1 equals, let me write this down for you. It's going to be 5ax plus 2a, and then you're going to get plus 3bx minus b. So what they do is they equate coefficients. What do I mean by that? That these two guys here better equate to that. Now what does that mean? 19 would be equal to 5a plus 3b. This equating coefficients. And this 1 over here better equate to these two constants here. I don't know what a and b is. So 1 would equal what? 2a minus b. Well, that's two equations, two unknowns. It looks pretty reasonable. I'm going to multiply the second equation by 3. Let me write that down for you. You get 19 equals 5a plus 3b. The second equation is going to be 3, 6a minus 3b. I'm going to add these two together. You get 22 equals 11a. The b's disappear. And a turns out pretty easy, just 2. I'm going to get my eraser out, and I'm going to erase the a now. And the a I'm going to write down as being 2. We'll check the key later. All right, now what I'm going to do. I want to get the b, and the way to do that is look at one of these equations I've written down. I'm going to say probably the easiest one to look at is this one over here. What would you get? 1 equals, well, 2a, if a is 2, would be 4 minus b. Well, looking at that, I think it's pretty easy, but maybe not. I'm going to say b is 3. Maybe I made a mistake. Let's take a look. Get my eraser out. Erase this over here. And I'm sorry, I erased too much there. Plus 3. Can put a box in this. Again, you get tired, you want to look at the answer key. Well, I'm going to look at the answer key and see what they said. Whoops, I didn't mean to put that in there. Oh, boy. Sorry about that. I'm going to look at my answer key. That's it right there. Look at my answer. Did I get the right answer? Yes. 2 over 3x minus 1, 3 over 5x 2. By the way, this is not my favorite technique. I'm going to do the next one, and I'll talk about my favorite technique. But again, your mileage may vary. You may say, I want to do it differently than you're doing it. The first thing I got to do is I got to factor the denominator. Now I'm looking at that. Let me put this on the side for you. X would come out. I would get 2 minus x squared. I'm going to factor that. X, I'm trying to factor into linear factors, by the way. Let's see, 2, 1, x and x minus plus. Let's see if that works. Let's see, 2 times 1 is 2. You get minus 2 plus 1 is minus 1. Yeah, it works beautifully. Now here comes the tough part. I got to write this down. I'm going to write down, you know what, I'm not going to put that. I'll put it over here. And what are you going to get? You're going to get one fraction with an x in it, we hope. One fraction with a 2 plus x in the bottom, we hope. And one fraction with the 1 minus x in it, we hope. All right, what do you mean hope? I hope we can get these things done. So A, B, and C. So the linear factor, we're just going to throw those A, B, and C's up there, okay? And let's take a look. Let me get my eraser out and get something there I don't want. And I'm going to multiply both sides by the LCD. We've done that in the past. All right, so what'd you get? Let's take a look at that. You're going to get x plus 4 equals A times 2 plus x times 1 minus x plus B times x, 1 minus x, plus C times x, 2 plus x. Now what I'm going to be doing, I'm not going to equate coefficients. To me, it's just way too much work to expand it. What I'm going to do is pick numbers that I find really easy to deal with. And one of the numbers I really like a lot is 0, because it's so easy to compute with it. Now if you did that, what would you get on the right side? You would get 4. Now what do you get? That's on the left side, by the way. What do you get on the right side? Well, the last two terms disappear. Again, as I'm doing this, I want to remind you, we're only looking at this now. That's all we're looking at. We're looking at this guy right here. And I'm picking numbers that I find easy to deal with. Again, I'm not expanding it. I may have to expand it, but right now, I'm not expanding it. All right, let's keep going. And again, if I took that, the last, x is 0, the last two terms disappear. And what are you left off with? You're left off with 2a. So I'm going to say this looks really easy to me. I'm going to say a is equal to 2. Now I can pick another number I think is easy. I can pick x to be 1. Now someone says, why are you picking that number? Because the first term and the middle term, but the last term remains. Let's write this down. If x is 1, you get 5 on the left side. On the right side, the first term disappears, the second term disappears, but what do you get for the third term? Now be careful about it. It's a 1, right? So you're going to get c times 3, which is 3c. Now that might be upsetting to you because you don't like the number, but I'm still going to write it down. You know, maybe I made a mistake. Who knows? 5/3. I need another number, don't I? Now I'm going to say another good number to choose would be minus 2. What do you get on the right side? 2. You know what? I realize I have to erase and maybe put in a different spot because I don't want to write over my typing. So I'm going to choose x equals minus 2. What do you get on the left side? 2. On the right side, the first term disappears, the last term disappears, but the middle term is going to be, let's see, minus 6. Let me check that. I don't want to say that's right until I check it. So I said minus 2, right? So 1 minus a minus 2, I'm using the middle term, is going to be 3, and 3 times minus 2 is minus 6. Yeah, looks pretty good. So what do I think b is? Well, I think b is going to be 2 divided by minus 6, which is minus 1/3, right? All right, someone says, I forget what you're doing over here. Well, I'm going to start plugging things in. All right, and I'm going to tell you, I'm going to do it over here. Let me come over here. Let me write this down. So I believe A is 2. So it's going to be 2 over x. We'll look at the key later. I believe B is minus 1/3. So I'm going to write that as minus, well, the B is 1/3, right? So I'm going to put the 1 in the top. I notice I got this doohickey. You know what? I'm going to go through steps here. I realize it's tough. Sorry about that. Plus minus 1/3 over 2 plus x. I'll do it in steps. I realize I'm going too fast there. Plus, I think C is 5/3, right? And that's 1 minus x. I'm going to clean it up. Go over here. Equals 2 over x. I'm going to multiply top and bottom by 3. I'll write a subtraction mark because it's easier for me to write that down. That would be 1. You know, 3 times the top. And you get 6 plus 3x. And then I'm going to multiply top and bottom by 3. I would get 5 and 3 minus 3x. Put a box on this. And I'm going to look at the key. And someone says, why do you look at the key? I want to see if I got it right. So 2 over x. This is the key, by the way, right over here. 2 over x. Gee, I got that right. Plus 5 over 3 minus 3x. Gee, I got that right. And minus 1, 6 plus... Oh, yeah, looks pretty good. Well, let's do this one a little more complicated. And what I mean by that, I'm looking at it's a cubic bottom, right? It's already factored, though. So I'm going to say probably it's going to look like x minus 3 plus x minus 3 squared plus x minus 3 cubed. But I don't know what goes on top. And you might say I'm dreaming that that's going to work. Well, they're written to work. What's the LCD? Well, that's easy. It's x minus 3 cubed. I'm going to multiply both sides by x minus 3 cubed. What do you get? X squared minus 11x plus 26 equals, well, it's going to be tough, right? A, x minus 3 squared plus b, x minus 3 plus c. Let the picking numbers begin. And someone says, what number are you going to pick here? I guess I'd pick 3. Looks the easiest one to pick. And what would you get? Now, let's write this down. 9 minus 33. I'm sorry, 33, because if x is 3, 3 times 11 is 33, plus 26. And what's nice about picking 3? The first 2 terms disappear, and we would get a c. So I think I can do it. And I'm going to say 9 plus 26 is 35, and 35 minus 33 is going to be 2. So I'm going to say c is equal to 2. All right, this is done. I'm not going to pick that again. Someone says, what number are you going to pick now? Geez, I have to pick an easy one. I'm going to pick x is 0. And what would you get there? You would get 26. And remember, maybe you don't remember. I'm going to put this down for you. We're using this equation here. That's all we're using. All right, let's keep going. Oh, I know c is 2. I'm sorry, I should put that down. So c is 2. Let me get my eraser out. Sorry about that. Let's keep going. I chose 0, right? So left side is 26. The right side, if I choose 0, I'll write this down. Be really careful. If x is 0, I get 9a minus 3b plus 2. Well, geez, what do I get? I'm going to take 2 from both sides. I get 24 equals 9a minus 3b. Wow, that's convenient. It's all divisible by 3. So I'm going to write this down over here. Is 3 goes into 24 8 times. 3 goes into 9a 3a times. And 3 goes into minus 3b minus b times. That's done. I'm not going to do that again. What's another nice number to choose? I'm going to say 1. Let me write that down for you. I'm going to say x equals 1. And what do you get? you get 1 minus 11 plus 26 equals, let's see, what would you get? You get 4a, right? And if x is 1, I'd get minus 2b plus 2. Oh, I got to figure that out too, don't I? So that would be what? 1 minus 11 is minus 10. Minus 10 plus 26 is 16. You're going to get 4a minus 2b plus 2. I'm going to take 2 from both sides. And what do you get? 14 equals 4a minus 2b. I'm going to divide both sides by 2. What do you get? 7, 2a minus b. Well, again, I got something that it's 2 equations, 2 unknowns. And certainly the way I'm going to do that is going to multiply the second equation by minus 1. And I think I can handle it. Let's see what you get. 8 equals 3a minus b. And minus 1 times 7 is minus 7 minus 2a plus b. Add it together, you get 1 equals a. So a is 1. Okay. Well, my gut feeling is to take one of these equations, like this one over here. And let's write it down. You get 7. If a is 1, you get 2 minus b. Well, you get 5 equals minus b, or b is equal to minus 5. I think I'm ready to write this down now. All right, let me get my eraser out. Let me see where my, I'm sorry, it's over here. I lost track of it. So I'm going to erase the a. I'm going to erase the b. I'll be careful. All right. What's the a? The a is 1. What's the b? The b was, what was the b? Oh, minus 5. Let me get my eraser. I write it in. Minus 5. I'm going to put a box in this. And I want to check it. Let's hope they have the answer down, right? So 1 over x minus 3. Gee, I got that right. Minus 5 over x minus 3 squared. Gee, I got that right. And 2 over x minus 3 cubed. Gee, I got that one right. All right, this one over here, let's do it. Again, I think it's going to be doable. It would be awful if it wasn't doable. So let's take a look. I'm going to put equals 3x plus 5 plus 3x plus 5 quantity squared. Again, I don't know the tops. I'm going to multiply both sides by the LCD. You get 6x plus 5 equals a times 3x plus 5 plus b. I'm going to pick a number that's easy for me to handle. And someone says, what's that number? So you could pick a fraction, minus 5/3, but I think that might be too tough. So I'm going to pick x as 0. And if you did that, what would you get? You get 5. Again, we're working with this equation here. 5 equals, I chose 0, right? So you're going to get 5a plus b. All right, let's see if I did that right. If 0, I'd get what? 5 on the left, 5a plus b. Pretty good. Now I'm going to pick x to be 1. You may wonder why I'm doing that, because it's easy. You can pick any number you like, by the way. 6 plus 5 is 11. That's on the left side. And what do you get on the right side? You get 8a plus b. Right? Let's take a look. And I'll write this down as a system of equations. It's going to be 5 equals 5a plus b. I'm going to take the second equation and multiply it by minus 1. What do you get? Minus 11 equals minus 8a minus b. I'm going to subtract the 2. What do you get? Let's see, you get minus 6 minus 3a. The b's disappear, and a turns out to be 2. Can I figure out the b? Of course I can. I'm going to take this equation here to do it. Let's write this down. 5 equals, well, if a is 2, this would be 10 plus b. What's b? B is clearly minus 5. I'm ready to get my eraser out and do this. Erase this here, erase that. I can start putting things in. So a turned out to be 2. We'll look at the key later. and the b turned out to be minus 5. Do mistakes happen? All the time. That's why we have an answer key for you. Look at the answer key. Right, you don't have to go through a bunch of work. Look at the answer key. What do you get over there? 2 over 3x plus 5? You got that right. Minus 5. This is the answer, by the way. Yeah, we did all right. Okay. This one, it's difficult. I'm not saying it's going to be easy for you. But the bottom line is, I hope you realize we're going to divide this into a bunch of parts. X plus 1, x plus 1 squared, and x plus 1 cubed. Wow, this is going to be a lot of work. A, B, C, and D. All right? I think I might need a little more space to do this. All right? So I just want to make sure you understand that this stuff is written down for a reason. I kind of see it nicely typed here. All right? Now, I realize what some people are saying now. What are you going to do with that? Well, the one thing I want to do is want to clear the fraction. I mean, this is an absolute requirement to clear that fraction. So I want to do that. I want to see what happens when I do that. And if I did that, I want to write down what you get. You get 3x plus 2. Wow, this is going to be tough. A, x plus 3 cubed. I'm sorry, I misspoke there. X plus 1 cubed. We'll check, don't worry. Plus bx, x plus 1 squared, plus cx, x plus 1, plus dx. All right, I want to just, again, remind you what we're looking for over here. And I want to make sure you know we're looking at something. You see that? Okay, what are we going to do now? My gut feeling is it can't be that much work. So I'm not saying I don't make mistakes. I'm just going to say I can't imagine much work in this problem. So I'm going to pick x to be 0. So why do you choose that? I think it's easy. So I'm doing that green highlighted equation now. You're going to get 2. And what would you get there? I guess you'd get a, right? Because the other 3 terms, right, all have a factor of x in it. They just disappear. So I'm pretty convinced that a is equal to 2. Let me highlight for you in the answer that we have a to be 2 here. All right? Now what I want to do is I'm going to pick another number that I believe is easy for me to do. I'm going to pick x equals minus 1. Now, by the way, when I say it's easy, I'm not saying I don't make mistakes. I'm just saying it looks easy. So, like, if I choose minus 1, on the left side, what do you get? Minus 3 plus 2, which is minus 1. And again, what's nice about having an answer key, you can actually verify what you're doing is correct after you do your work. So if I chose x to be minus 1, I have the first term on the right side would disappear, the second term would disappear, the third term would disappear, and then lo and behold, I'm left with minus d. So I'm going to say, this looks pretty easy to me, where d would be equal to 1. I'm going to outline that for you, and that's right over here. All right? Now I got some problems on my hand. Someone says, what are you going to do now? I need to pick another number. Someone says, what number would you choose? Well, I got to stick easy. So what I'm going to do, I'm going to try x equals 1. Now, if you're tired, you're going to make mistakes. If I chose x to be 1, on the left side, what would I get? 3 plus 2, right? 3 plus 2, which is 5. All right, now what do I get on the right side? This is going to be more difficult. A is 2. And then I get 1 plus 1, which is 2, and 2 cubed is 8. Let's do the next term. What's it going to be? Well, I'm going to get b times 1, which is b, and 1 plus 1 is 2. 2 squared is 4, so I'm going to get 4b. I repeat that. I'm plugging in 1. 1 plus 1 is 2. 2 squared is 4. 4 times 1 is 4. 4b. Let me go to the next term. What are you going to get there? 2 times 1 is 2. 2c. This is tough. I'm not saying it's easy. What's d? D is 1. What's x? X is 1. I got to clean this up. 5, 16, plus 4b, that's a b, plus 2c, plus 1. Let's see, 5, this would be 17, 4b, plus 2c. Yeah, there's 2 unknowns. Take away 17 from both sides. What do you get? Let's see, you get minus 12, right? 4b plus c. I always say the more work you do, the more likely mistakes are going to happen. I'm going to divide by 2, though. You get minus 6 equals 2b plus c. I still don't know what b and c are. All right, so I got to pick another number. So what number are you going to pick now? I don't know. Let's think about it. I'm going to pick minus 2. Now, again, someone said, I don't want to pick minus 2. I'm going to pick another number. I'm going to pick 7. Pick any number you like. All right, so what do you get minus 2? What do you get? Minus 6 plus 2 is minus 4. All right, remember, I picked minus 2, right? What's a? A is 2, isn't it? And what's minus 2 plus 1? That's minus 1, and minus 1 cubed is minus 1. Let's go to the next one. Well, more complicated, but I get minus 2 plus 1. The second term, by the way, is 1. 1 squared, minus 1. That's going to be squared 1. So I can get minus 2b. Oh, boy. This is going to get tough. What do you get? Minus 2 times minus 1 is 2, so I get 2c. Oh, d. What's d? D is 1, and minus 2 times 1 is minus 2. Now, it's going to be tough, isn't it? Minus 4, minus 2, minus 2b, plus 2c, minus 2. Wow, that's not so bad, is it? I'll tell you why. I'm seeing the right-hand side. It's minus 2 is minus 4. So I'd add 4 to both sides. I get 0 equals minus 2b plus 2c. Well, you know what I got to do now? I got to divide by 2. I'm going to divide by minus 2. What do you get? 0 equals b minus c. What does this mean to me? B is equal to c. Whatever they are, they're equal. I still don't know what they are. So what I want to do, I want to take this and go up here and make a substitution. I didn't mean to do that. I'm going to do a substitution. Let me see what I get. Minus 6. If b equals c, I'm going to say it's 2b plus b. Again, b equals c. Minus 6 equals 3b. B would equal, let's see, that's minus 2, right? So that means c is equal to that too. All right? So do I know everything I need to know? I do. Let me outline where this is in your notes, by the way. So I told you that the b is minus 2 and the c is minus 2. So we figured those all out. I want to go back up here, and someone says, I have no idea, I can't remember anything. Well, let's put it down. Let's write this down. So I'm looking at this. I want to point out what I'm looking at. What's A? A is 2. Whoops, I didn't mean to do that. I just think I lost everything. I don't know how I did that. Give me 1 second. Yeah, for some reason I just lost everything. But let me go back over it. I apologize for that. I think we just, I'll outline what I believe we just did. We had, I'll write that down for you. We had A over X plus B over X plus 1 plus C over x plus 1 squared plus d over x plus 1 cubed. And we figured these things out. I'll outline what I figured out before. And sorry about that. I must have pressed something. I don't know what I pressed. But I believe we already verified that. We verified that. And we just did this in the very final thing. I'm going to write these down for you one at a time. A is 2, so it's 2 over x. The b was minus 2. That's going to be minus 2 over x plus 1. We'll look at the key later. And what's the c? The c is also minus 2 over x plus 1 squared. And what was the d? The d was 1, so we can get 1 over x plus 1 quantity cubed. And that was the final answer over there. That's right over here. I'm getting every single thing I expected to get. All right, I know this is tough. Right, I sometimes I say it's tough, but it's really not tough. It's just tedious. All right, so what are you going to do now? You're going to do the exercises, all right, one at a time. I do put work down for you. The reason I put work down for you is some students need to see the work. Not everybody. What's the work going to be? Well, that varies. But for the most part, I take a traditional approach, non-traditional approach, whatever approach you like, you get it. I put a lot of work down, but I do put the answer. It's right over here. If I were doing this homework, though, I don't know if I'd look at my work. What I would do is I'd do the problem. I would follow the steps. What I mean by that, I'd look at this over here. I'd say A over 2x minus 3 plus B over 2x plus 3. I'd clear the fraction. I might equate coefficients or just simply pick numbers for x to make it simple for me. But then I'd look at the final answer. There's a lot of work here, right? And I would want to make sure I match that over there. For all the problems, exactly what I'm going to be doing. All right, exactly. Some problems have more work than others, but again, they all have answers, and you want to look at those answers. Some might be more difficult than others, but the bottom line is I put down some work. I put an answer down, certainly. All right? Someone says, oh, it's too many problems. The more effort you put into this, the easier it becomes. Right? The more effort, the easier this becomes. Yep, there's a large number of problems there. There's going to be 23 problems. Be able to get to it in a reasonable amount of time. Just I will remind you about the SAGE. What's SAGE? It's a computer algebra system. That's abbreviated CAS. It's free. What do you mean? It's open source. Go to this website over here. Either download it or use the interactive web-based application and type in some code. All right? So there's a new command over here. I want to put what the command is. It's partial fractions. SAGE can do partial fractions, and it does a really nice job at it. So what's this? How could it do it? Whoever coded SAGE knew what we were doing. That's all they're doing. They're coding that. It's very methodical, by the way. Most algebra is very methodical. What does it require? Factorization, equating coefficients, or selecting values to make it easy for you to evaluate what those constants are. All right, and that's about it. Thank you for paying attention. And again, if you need to reach out to me, my email address is Bannon. That's B as in boy, the @ NNON.US. Thank you.